In this video, we'll discuss whether we can top up an inverter AC system that uses R410 refrigerant. Additionally, we'll explore the reasons why an inverter AC system with R410 refrigerant might experience a blast. We'll cover all these aspects in detail today and examine the causes and the correct procedure for safely topping up such a system. Now, let's look at the literal or dictionary meaning of top up. According to the dictionary, top up means adding more to something that is low or insufficient. For example, if we talk about gas and the unit has a low amount of gas, we'll add more gas to bring it up to the required level. This process of increasing the gas is what we call a top up. After topping up, we might face two types of conditions, a good condition and a bad condition. Besides these, we'll also look at the advantages and disadvantages of each, understanding what will work in our favor and what might cause issues. This is because there's often a difference between theoretical information and practical experience. So we'll mostly focus on the practical aspects in this discussion. Now, let's look at how companies charge gas in AC units. What companies do is, when they install brand new systems, they test and inspect them by filling the unit with gas and determining exactly how much is needed, whether it's 1 kilogram, 2 kilogram, or another specific amount according to the system's requirements. Based on their findings and experience, they then standardize the gas quantity. So, for all subsequent units they manufacture, they charge the same weight of gas, ensuring the unit operates perfectly. However, if the unit is taken outside the company, such as when it's installed in a customer's location, and after 1 or 2 years it develops issues, then what is the best way to handle it? In today's video, we'll definitely look into the best methods for addressing such issues. In my opinion, the best method I've learned through practical experience is to charge the gas slowly. The reason I say this is that when you charge the gas gradually, you can better identify any problems within the system, such as damage to the compressor or a blockage in the expansion valve or capillary tube. This way, you can determine if your system is malfunctioning and avoid adding more gas unnecessarily. If you rush to charge the gas all at once, you risk damaging the compressor, especially if the compressor isn't able to handle the load. I've experienced situations where, during a slow charging process, the compressor struggled to operate properly, indicating that there was an underlying issue. Conversely, when the system was running with the correct amount of gas, it performed well. If I had charged the gas all at once by weight and then tried to run the system, the damage could have been much worse. Charging slowly allows you to minimize the risk of greater loss, like damaging the compressor or wasting gas. Therefore, the best approach is indeed to charge the gas slowly. When you're doing a top-up and charging the gas slowly, timing becomes very important. For example, if you're charging the gas slowly under consistent conditions, you must first ensure that any leaks in the system are properly sealed. After that, you should vacuum the system thoroughly and check that there are no leaks to make sure it's airtight. Only after these steps should you start slowly charging the gas, as this will be a safe and effective top-up. This method ensures there's no air inside the system and reduces any risks associated with contamination. In my opinion, this is what makes for a good, reliable top-up. Now, let's talk about a bad top-up situation. Even if you've installed a brand new unit and used it for only a night, a day, 2 days, or 4 days, or if you're topping up an old unit after several years, certain issues can lead to a bad situation. When the gas level in the unit is low, there's always a reason for it, and it's usually due to leakage. There might be a broken pin somewhere or a faulty flare connection, which causes the gas to decrease. Otherwise, the gas level doesn't go down on its own. If you add gas to the unit again without addressing the underlying issue, this would be considered a bad top-up. For example, even if you've removed the remaining gas from the system, if you don't vacuum it properly, this would also be a bad top-up because air will still be present inside, which can lead to problems. That's why timing and proper preparation are very important. Only then can it be considered a good top-up. In this video, you can see that one of our viewers sent in a video where the unit experienced a blast at the terminal. It wasn't a complete blast, but they asked about the reasons behind it. Today, they will get an answer as to why the terminals exploded in this case. We will discuss the potential causes and provide an explanation for what went wrong. In addition, one of our viewers commented saying that charging the gas slowly is not a good method. Today, we'll explain why this approach can actually be safer. The unit can potentially burst or even cause an explosion, but these are two different situations. When we look at the safety matrix, which you can see on the screen, we see that R410A refrigerant is non-toxic and non-flammable. This means that under normal atmospheric pressure, it won't catch fire or cause any harm. It is also considered an eco-friendly gas, making it safer for both the environment and the system when handled correctly. Now, let's talk about unit blasts. For a unit to explode, 3 specific conditions must be present. Otherwise, the unit is more likely to burst, but it will not actually explode. To understand this, let's first look at what happens when a unit bursts. The unit will burst if the internal pressure becomes excessively high. But before we dive into that, let's understand how much pressure a normal unit works with. Typically, the discharge pressure of a unit can reach up to 400 psi. If we look at the suction pressure, it can go up to around 150 to 180 psi. In this situation, the unit will not burst or explode. If any issues arise, they'll typically cause the system to shut down. However, when the pressure reaches 3000 psi, that's when the unit can actually burst. The reason for this is that the copper tubes used in the system have a pressure tolerance of up to 3000 psi. Once the pressure reaches this threshold, the copper tube will fail and burst. Different components in the system have varying pressure limits, and the unit's failure will depend on the specific part that reaches its limit first. For a unit to actually blast, 3 conditions must be met. First, a strong flame or spark within the system can significantly increase the chance of a blast. The second situation is when excessive air is present in the system. If there is a large amount of air, the risk of a blast becomes 100%. The third condition involves extremely high pressure within the system. Normally, units don't explode under atmospheric pressure, but if the pressure is extraordinarily high, the likelihood of a blast increases. If all 3 of these factors are present, the unit is at high risk of exploding. However, if even one of these conditions is absent or reduced, the unit will not explode. These are the critical situations that could lead to a potential blast. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.